Hello, ladies and gents. So, as promised, this is a video that gives you proof for the product, quotient, quotient, and the chain rules. Now, you don't need to know it. Okay? So, it's beyond the level of the AP course. So, again, no need to know it. You don't have to watch this video. All you really need to know is how to apply these rules. But if you're curious, okay, and you want to know where these rules come from, stay with me, and I think it will take about 15 minutes and we'll prove them. We're going to start with the product rule. So I've got a multiplication, a product of two functions, and I want to find the derivative. So we're going to work by from first principle, okay? So df of x times g of x to dx, okay? The definition of derivative is basically f of x times g of x, or not, let's write it like this, sorry. Yes, so basically what I need to do, I need to find out the difference, okay, the delta y over delta x, where delta x is approaches 0. So we're going to find the x plus h. Okay, let me just write it in, I'll just write it like that. f of x plus h times gx plus h minus fx times gx divided by h in the limits where h approaches 0. Let me try and explain that. So we find the value of this product of the function at x plus h. We minus the value of the function at x. We divide by h, the difference between x and x plus h, and we make the limits where h equals to 0. Now what we're going to do here is a little trick, cunning trick, okay? We're going to do the same thing, limit h approaches 0. We're going to write fx plus h times gx plus h, okay, that first term. But now we're going to introduce like an artificial term. We're going to say minus f of x times gx plus h, just a made up term. So if I'm minusing here, I must also add it. So I'll add it again, f of x times gx plus h, okay? And then finally, I'm going to do fx times gx. All that times h. So you can see what I've done here. Okay, I took these two terms, I wrote them, and I minus and added the same term. Why? You'll see now. Now I'm going to divide into two fractions. So that's going to be one fraction. Let me just see that I've got it right. Yes. So that will be one fraction, and that will be that one fraction. So I'm going to write in the limit h approaches 0, f x plus h gx plus h minus fx gx plus h, that's going to be one term divided by h, okay, plus, now I'm going to write the next one, fx times gx plus h minus f of x times gx divided by h. And I'm using the same limit. I really should write limit h approaches 0. So I split it into two fractions. Now, what can I do? I'm going to start it here. Give me a little bit more space. Limit h approaches 0. I can factorize. Look, I've got gx plus h on both sides. So I'm going to write down. Okay, all right. Gx plus h, common factor, time fx plus h minus f of x divided by h. Okay, so I just took the gx plus h out. Okay, and I'll do the same thing here. What kind of common factor I can take here? You can see the fx. So I'll take plus, I'll write first of the limit, h approaches 0, fx, open brackets, gx plus h minus gx divided by h. Now I'm almost there. Let's have a look. Now what I'm going to do now, I'm actually going to look at the h approaches 0. Okay, so I'll stand here, hopefully you guys can still see me. In the limit when h approaches 0, okay, what is gx plus h? Well, h approaches 0, so basically it's gx. Okay? Because x plus h is almost the same as x. But what is that? That's more interesting. What is this quantity? F of x plus h minus f of x divided by h, and h approaches 0. Well, that's simply the definition of the derivative of f. That's f prime x. Okay? So what I've got here, I've got d of fx times gx. The derivative of the product of these functions is first of gx times f prime x plus, what do I have here? Well, now I've got f of x, and what is this term? Okay? In this term we have gx plus h minus gx divided by h. That's the difference in the g's divided by the difference in the x's. That's exactly the derivative of these. So it's f times g prime x. Okay? And what have we done it? Okay, the derivative of a product of function is simply one function times the derivative of the other function plus the first function times the derivative of the other function. I'll just swap things around. Okay, the f prime got swapped with a g, but otherwise it's the same. Okay, so that is the product rule. Fantastic. Let's move on. Okay, so now we're moving on to the quotient rule. Now, it probably is possible to do it through first principle with the definition of derivative, but I wouldn't go that way. It's not needed. What I'm going to try and do is turn this f divided by g into something that looks more like f times g. And actually, it's really easy. You can do it. You'll love it. It's so easy. Okay? So, first of all, what I'm going to do, I'm going to write f of x divided by g of x in a way where it's more like f times g, because the product rule gives me a way of dealing with f times g. Okay? But how can I write f of x divided by g of x? Easy peasy. Okay? It's simply f of x times g power minus 1 of x. That's it. And now it looks like a product. It is a product of two functions. Okay? So I'm just going to use that now to find the derivative. I mean, you're going to use the product rule. Okay? D of dx of f times g minus 1. Okay? I mean, that is differently, that is the division of these two functions. But now I'm going to use the product rule, and I will need a little bit of the chain rule, which we'll prove last. Okay, so what does the product rule tell me? So it tells me, okay, you've got multiplication of two functions. First, find the derivative of one of them. Okay, that's the derivative of f to x, so that's f prime x. And time it by g minus 1x. Okay, now put the next function, the first function, f, and time by the derivative of the second function. What's the derivative of the second function? G minus, or what's the function? G minus x. Let's just write that separately. What is the derivative of g minus x to x? So here we need to use the chain rule. Okay, what is the chain rule? Remember with the babushkas. Okay, so I've got some kind of function of a function. The function, the inner function is gx. The outer function is, tell me, I'm doing power minus 1. So I'll start with the derivative of the outer function. Okay, what is the derivative of g minus 1x? Is minus g minus 2, g power minus 2, okay, minus 1 comes out, times g to the power minus 2. And now I need to multiply it by the derivative of the inner function. What's the inner function? The inner function is g. So I'm going to time it by the derivative of g. Okay? So now I'm going to write that here, because that's what we were trying to do. Find the derivative of g minus 6. So I'm going to write that down here. Time minus g minus 2 of x, okay, time g prime x. Okay? I'm going to erase this. Okay? Now that doesn't look like that. But we're going to make it look like it. It's not difficult. Okay? Because I've got minus 1. Let's write it again. So it's going to be f prime divided by g of x plus, what do I have here? Or not plus, actually I've got a minus, g minus 2. So I'm going to have g squared x at the denominator, f of x at the top, times g prime x. Okay? We're getting somewhere. We're finishing it up now. I think we're going to finish it up. So I'm going to write again. df of x divided by g of x, the derivative of df over g, dx, and I will pretty understand what I'm doing there, is simply, I'm going to just put the common denominator. The common denominator is going to be g squared of x. I need to multiply that by gx, so it's going to be f prime gx. I have to multiply by g once, minus, this is one is already sitting on g squared, so I'm just going to write it as it is, fx times g prime x. And you can see here, we've got the quotient rule, okay? It's just application of the product rule, okay? Last one, we're going to go for the chain rule. Okay, so now we're down to the last rule, the chain rule, okay? The derivative of a function, a composite function, is equal to the product of the derivative of the function of the function times the derivative of the inner function, okay? So let's, again, we're going to use the just first principle, the definition, okay? So d of f of g of x to dx is basically f of g x plus h, okay? So we're pushing the x a little bit forward, h, okay, and substituting into g, getting the g and then putting that into the f, minus f of g of x divided by h, requiring or putting it where the limit is h equal to 0. Okay, so approach it 0. Okay. What we're going to do now, we're going to do this. We're going to do another trick, but a bit of a different trick. So we're going to take this bit, okay, I'll write down the limit, h approaches 0, f g x plus h minus f g of x, divided by gx plus h minus gx. So we made up a term. You know what we're running out of space here. Let's write it again here. Okay, so I'm going to take the whole thing here. F gx plus h minus f gx. Okay, I'm going to write like this. Okay, so I'm going to multiply now. Multiply two fractions. Put the h on this side. I can do that. Okay. And then I'm going to divide and multiply by the same term. And the term is gx plus h minus gx. Okay? So if I divide it by here, obviously I need to multiply it by there. Okay. Okay? So you can see if you cross cancel these two, voila, you get back the same thing. Okay? And obviously I need to require that h approaches 0. Now what did I get? Okay? What did I get? Okay? I'm going to write again df gx to dx. That's what I was started with. I'm getting two terms. I'm actually going to start with the second term. I think it's a bit easier to kind of see it, to visualize it. What is gx plus h minus gx divided by h in the limit where h approaches 0? That is very clearly the derivative of g. Okay? So this bit is simply g prime x. That's the definition of the derivative of g. Okay? Which is great. Okay? And the second one was the derivative of g. So all I'm going to do now is convince you that this first fraction is in fact, you can see I'm just missing a little bracket there. This fraction is really the derivative of f. And that's going to be a bit trickier for me to convince you, but I'll try my best. Now, here we go, I'm missing these brackets. You know, what is a function? A function is something where you put something in it and it spits out another number. Okay? Well, a composite function is I'm putting a number, x plus h, put it inside a function g, and then all that I put into f. So what I'm trying to say is that in f of g of x, this bit, the g of x, is like your x. It's not the same as x, but it's like your x. This is the input. The input I put into f. So g of x plus h is your input. Okay, that's the input. So what do I have here? Okay, I've got the value. I've got this thing in English. I'll translate this math into English. This thing, the top bit here, tells me this is the difference in the values of f between g of x plus h and g of x. Okay, so I've got gx and gx plus h, these are two values, like two x's that are put inside these f's, and this term tells me that's the difference between them. It's like your delta y. This is like your delta y. Okay? That's like your delta y. Okay? What is gx plus h minus gx? This is the difference between the x. Because remember, this thing we said, this whole thing is like your x. So this is x plus h, and this is like x. This is like your delta x. So what do I have here? I've got basically delta y divided by delta x. In the limit, what does it say? When h approaches 0, what does it tell you about delta x? It tells you delta x is very close to 0. The difference between x plus h and x, okay, which is h, is very similar, close to 0. So this thing tells me this term is delta y over delta x in the limit where delta x approaches 0. And what is that? Of course, that's a derivative. Derivative of what? Of the function f. Okay? So that, I'll use another color. Use a red color. Okay? This baby here is f prime g of x. And we multiply them. Okay? Chain rule. Grade 12, chain rule. Fantastic, guys. I'll see you later.